Hi again, Bobcats. In this video, I'm going to work two example problems. One will be a mole conversion problem, and the other will be a stoichiometry example. All right, this problem wants to know how many molecules of sugar, and we'll use the formula C6H12O6, which is glucose, are in 4 grams. 4 grams is roughly a teaspoon of sugar. So we're going to start this process by writing down the number, the unit, and the chemical that we're given. So we have 4 grams for the number and the unit, and then the chemical is C6, I should have picked a shorter one, H12O6, although I'm getting a little bit better at writing with this drawing tablet. And we're going to place that over 1. The 1 is just there to make it look like a fraction, and so the 1 does not have any units associated with it. Then we're going to multiply what we were given by our conversion factor. Now, on the bottom of the conversion factor, we need to match the unit and the chemical that we were just given. So we can write grams of C6H12O6 immediately. In the top, we want to write the unit and the chemical that we're looking for. We are looking for molecules of sugar. And so up top, I'm going to write MC, which is the Patterson abbreviation for molecules. It's not a standard one because there isn't a standard abbreviation for molecules. So I've got molecules of C6H12O6. Then I'm going to fill numbers into the front part of this conversion factor. How many numbers do I need? Well, let's look at how many chemicals we have. In the top, I have glucose or sugar, and in the bottom, I have glucose or sugar. That's just one chemical, so that means I just need to put one number in to fill out these conversion factors, and that one number comes off the radiation sign. On the radiation sign for molecules, we have the number 6.02 times 10 to the 23rd. And on the radiation sign for grams, we have the molar mass. The molar mass means the molar mass of glucose. So if I go to the periodic table and I look up carbon, it has a molar mass of 12, but this formula has 6 of them. So for the carbon, I'm going to take 6 times 12. Then I have 12 hydrogens, and the mass of each hydrogen is 1. And then I also have 6 oxygens, and the mass of an oxygen is 16. If I run all of that through my calculator, I come up with 180 grams. So I'll fill in 180 grams on the bottom. And now we just need to run that through a calculator. You can pause this video and run that calculation. I'll give you a moment here to hit the pause button. All right, when I ran this through my calculator, I got 1.34 times 10 to the 22nd molecules of glucose. All right, there we go. This is an example of a mole conversion problem because we only needed to put one number in the top and bottom of our conversion factor because there's only one chemical involved. Okay, in this problem, we're asked how many molecules of sugar can be made by photosynthesis if 25 grams of carbon dioxide react. And we're also given the balanced chemical equation that 6 CO2 plus 6 H2O yields C6H12O6 plus 6 oxygens. Well, let's start this by writing down the number, the unit, and the chemical that we were given. So I'll start by writing down 25 grams of CO2. Now I'm going to multiply this by a conversion factor. The bottom of this conversion factor needs to match the unit and the chemical of what we were given. We were given 25 grams CO2, so the unit and the chemical on that are grams of CO2. The top needs to match the unit and the chemical of what we're asked to find. Well, the sentence starts, how many molecules of sugar? So that tells me the unit is molecules and the chemical is sugar, C6H12O6. Now, in the last example problem, both the top and the bottom had the same chemical in them. It was glucose in both places. But this time around, it's CO2 in the bottom and glucose in the top. So that means we're working with two chemicals. Two chemicals means that we have to put two numbers to complete our conversion factor. The first number comes from the radiation sign, and the second number is the coefficient from the balanced equation. So up top, I've got molecules. On the radiation sign, that's going to be 6.02 times 10 to the 23rd. Then in front of this number from the radiation sign, I'm going to put the coefficient from the balanced equation. And for glucose, that coefficient was 1. Down in the bottom, I need the number on the radiation sign that has grams. Well, grams goes with the words molar mass. And so we need to go to the periodic table again and add this all up. Carbon has a mass of 12, and there's 1 carbon in this formula. So we'll take 1 times 12. And then there are 2 oxygens, and each oxygen has a mass of 16. If we add all of that up, we get 44 grams of CO2. So 44 will go down here with the unit of grams. And then I need a second number since we had 2 chemicals, and that second number is the coefficient from the balanced equation, which is a 6. Now I just need to run this through my calculator. Remember in class we talked about some of the difficulties that go with this. And if you're doing it all without any parentheses, you need to hit the divide key each time you have a number that's in the bottom, and the times key each time there's a number in the top. So I would type in 25 times 6.02 EE23. Then I've got 2 numbers in the bottom. So I'll hit divide by 6, and then I'll hit divide by 44. What your calculator understands is that the divide key means the numbers in the bottom, the times key means the numbers in the top. And my calculator is telling me 5.70 times 10 to the 23rd. Whoops, that's not a 3, that's a 2. Times 10 to the 22nd. And then the units here, it's molecules of C6H12O6. Sorry, I still haven't figured out the best way for erasing. So that's a 22 up there.